So today I'm going to be talking about venom and social behavior and how we might use spiders to evaluate the evolution of sociality under high-risk conditions. So just an overview, I'm going to start out by talking about sociality in arachnids and specifically spiders. Then I'm going to go on to talk about risk assessment and how the spiders might use that, and then social risk that we see in spiders, and then finally social learning. So spiders are often considered solitary, but there's actually 8 families of fully social spiders, and these are divided into 2 types. We have cooperative spiders and we have communal spiders. So cooperative spiders are ones that work like sharing food and hunting together. Communal are ones that live together, like sharing the same web but not sharing prey. And the spider that I'd really like to focus on in this talk is Latrodectus, or the widow spiders, because although Latrodectus is not considered to be a social spider, they actually have several different social behaviors, such as the juveniles actually live together and share food, and then the adult females will live together in the fall and winter months before dispersing for mating season in the spring and summer. You see, although we have the different levels of sociality that we consider, social and solitary, and subsocial, there's actually many species that fall in between. And those species can be the key to looking at the evolution of social behavior, because in spiders, we see a wide range of sociality from solitary to social. And we also see a few key differences and similarities. So spiders could be a very good system to look at the evolution of sociality in cannibalistic and venomous organisms. So let's talk about the differences and similarities between solitary and social spiders. One of the big similarities that we see across the board is kin recognition. Cannibalism is a part of basically every spider species and interaction that we see. And kin recognition is also a big part of that, because we notice that spiders of both solitary and social species will show preference for cannibalization of non-kin over cannibalization of kin. One of the big differences, however, is inbreeding. We notice that social spiders are a lot more inbred than solitary spiders, likely because they primarily breed and mate within their social group and really do not interact with other social groups outside of that, which also helps with kin recognition, because all of the spiders that you're living with are related to you. Now, venom. So this is something that we see in wasps, and Hymenoptera is the other big taxa that we use to look at social evolution, because Hymenoptera is the other big taxa that has everything from solitary to social species. And in Hymenoptera, we see something very interesting with venom, in that there's very different utilizations of venom between solitary and social wasps. You see, in solitary wasps, the venom is primarily used for hunting and capturing prey, whereas in social wasps, the venom is primarily used for defense of the colony. In this way, venom could actually be very useful for social groups, because it provides a very valuable defensive resource. And the difference in utilization really points to the evolution of venom and how the evolution of venom might tie into the evolution of sociality. Now, in every creature, both solitary and social, risk assessment is something that is very, very necessary. It is necessary to be able to analyze risk and respond accordingly. So we see that in spiders, primarily with venom metering, which we will talk about later, but with also a few specific examples. For example, we know spitting spiders and Portia spiders. Portia spiders actually prey on spitting spiders, and they are very smart and analyze risk depending on the situation. You see, spitting spiders spray this mixture of venom and spit, which is obviously very dangerous to a potential predator because it will tangle them up just like prey. So in most situations, Portia spiders will attack spitting spiders from the back because, well, they can't spit from the back. However, when spitting spiders carry their egg sacs because they'll carry them in their jaws, Portia spiders will attack them from the front because in that situation, the front is safer. And so the Portia jumping spiders analyze the situation and respond accordingly for how they interact with their prey. Web spiders also do something similar. Whenever a high-risk prey, such as an ant or a wasp or other hymenopteran, lands in a spider web, usually the web-spinning spiders will not go after it and instead let it escape because there is too high of a chance of it stinging them and injuring or potentially killing them. In fact, we see that hymenopterans and other risky prey make up a very small percentage of the prey of these web-spinning spiders. So we usually talk about risk assessment with invertebrates and arachnids in terms of prey and predators, but there's actually a bunch of the social risk because in a cannibalistic species, especially like socially cannibalistic species, you have to be able to analyze what the likelihood of you getting cannibalized by another individual is and respond accordingly to that. So one way that we really see evidence of risk assessment is in venom metering. So we see a couple interesting differences. So younger spiders will rely on more evasive behaviors and older on more aggressive. And we see similar with smaller versus bigger spiders. However, as spiders get more experienced, they rely more on evasive behaviors and less on aggressive behaviors when encountering prey because if they can use less venom, then that is more beneficial to them. This even goes so far as to, when escaping predators, doing this thing called dry bites in which no venom at all is injected. We also see that the venom itself changes as spiders grow from juvenile to adulthood, and this change in the contents of the venom might be very interesting when looking at the evolution of that venom and how venom metering is carried out. So in social risk, with a big risk is cannibalism. So we know there's several types of cannibalism. There's sibling cannibalism, there is autophagy, such as the juveniles eating the mothers. And what we mostly talk about in terms of cannibalism is sexual cannibalism, and that's what's mostly studied in spiders. So we know that Latrodectus black widows are highly sexually cannibalistic. In fact, 3 known species of widow spiders will actually, the males will actually invite cannibalism from the female. Now, this might seem kind of counterintuitive. How is this assessing risk and responding to it? Well, the answer is that when searching for females, the females are spread out, and the chance of a male dying before finding a second female is very high. So it is actually more advantageous for the male to put all of their energy into that one female, not only providing nutrients to the female, but also the longer that the female is working on consuming the male, the more sperm that the male is able to insert into the female, and thus the more sperm precedence the male has and more likelihood to fertilize more of the eggs. Now, some other species of Latrodectus do not invite cannibalism. In these, they do some other strategies instead that might help with sperm precedence, such as finding the young females, the ones that are not actually fully adults, and mating with them before they turn to adulthood. And these females are also incidentally less likely to cannibalize the males. Additionally, some of these males will look at pheromones, and they can tell whether a female is hungry or full, and which gives them a good assessment of how big the risk of mating with that female is, because hungry females are much more likely to cannibalize the male. What we do not really what we have not really looked into much with social risk and cannibalism is its interactions with social learning. So in social learning, besides the mating preference of mating with the more full females, there's also a very valuable thing called communication. So they communicate with these pheromones, but also with vibratory signals and such that can maybe say, like, back off, this is my web, or something similar. Overall, we know a lot about risk assessment in spiders when dealing with predators and prey, and we know a lot about cannibalism when dealing with sexual cannibalism, but what we do not know much about is how cannibalism and venom interact, and whether venom is used in social cannibalism. We also do not know how these might interact with social evolution, but by looking at the interactions between venom and cannibalism and the social evolution, we might find a lot more good insights into how sociality evolves, especially in these cannibalistic and venomous species.